welcome back. Your dreams were your ticket out. Welcome back to that same old place that you laughed about. Well, the names have all changed since you hung around, but those dreams have remained and they've turned around. Who'd have thought they'd lead you? Who'd have thought they'd lead you? Back here where we need you. Back here where we need you. Yeah, the tease in my lot, 'cause we got him on the spot. Welcome back. Welcome back. Welcome back. Welcome back. Welcome back.
Welcome back. All right, give it a stretch. Okay. All right. So, welcome back. For this break session, I wanted to take a look at this thing I've been watching on the internet and on YouTube particularly. And it's a whole playlist from Google Chrome for Developers channel. And I'm going to post a link to it and save it. So it'll be next to the recording of this video. And I figured to take a look at some of the videos. It's pretty dope, some interesting stuff. So let me share a screen. Now, some of it I can't really run on my computer because I'm doing all this streaming stuff, but they have like links to different demos and stuff. So it was a state of web AI in 2024. And they've been releasing it like over the past couple of weeks. And so like the latest one that like just had some a few days ago, like a day ago. And so some pretty cool stuff here. So here's the whole state. So let's take so this is like it says here, state of client-side machine learning. You know what I mean? And so let's take a quick look at this one. This one's pretty interesting.
Welcome everyone to the first ever Public Web AI Summit. Woo! I'm Jason Mays, Web AI lead here at Google, and I'll also be your host for today and one of your presenters. Now, I started this summit a few years ago internally to share knowledge between Googlers in this field, going from around 10 to around 1,400 of us in just 2 years. And after speaking to many of you at events, I heard feedback that you wanted to start something more official for everyone to be part of too. So today, in our third year, we're making the Web AI Summit public to bring together great minds working across this space from all around the world, both here at Google and also from beyond too. So what can you expect? Well, you're going to hear from a whole bunch of great presenters from over 20 teams across companies.
So pretty dope, right? Now, so we spoke about this one before, Transformers.js. I think we did a demo, and I think maybe my browser might have crashed or something. But the person who transpiled the Python transformers to JS gave a talk. And so take a quick listen to that.
Good morning, everyone. My name is Joshua, and I'm excited to talk about Transformers.js, a library we're developing at Hugging Face that brings state-of-the-art machine learning to the web. First up, a small introduction, starting with who am I? Well, I suppose you may know me better by my X logo profile picture or my Twitter or GitHub username, Zenova. But in reality, I'm a 24-year-old machine learning engineer from South Africa.
Cool. So now some of the stuff that they did, let's see here. You can get, so real quick, so you can kind of see some of the demos here. I think we went through some of these before, but you can check it out.
Next, let's take a look at what you can build with Transformers.js. To start, I just wanted to take a step back and talk about the development philosophy that we follow. First, new model releases, for example, Llama 3.2. Next, we add support to the library. Typically, this involves converting the model to Onyx and updating the library with the correct configuration values. But luckily, since the Llama 3.2 architecture was the same as previous generations, we could just reuse our conversion scripts. If it was a new architecture, the process would be a bit more complicated, first adding support to the Python Transformers library, then adding Onyx export support, and then finally integrating it into Transformers.js. Lastly, we create visual and interactive web demos and publish the source code to GitHub. Not only does this help us increase the visibility of the project when posting to social media, but also showcases what is possible with the library. By publishing the source code, we hope that developers can learn from it and adapt the ML components into their own projects. So now let's take a look at some applications that have been built with the library. Starting, of course, with privacy-focused chatbots that run 100% locally in your browser. The model shown here is Phi 3.5 Mini, a 4-bit quantized 3.8 billion parameter LLM from Microsoft that is optimized for inference on the web. Thanks to a specialized multi-head attention web GPU kernel, it can run up to 90 tokens a second on an RTX 4090. We also added support for multimodal chatbots, meaning the model can process and respond to image inputs too. The model shown here is Moondream 2, a small vision language model designed to run efficiently on edge devices. We also, when we added support for these models, we also added the ability to reuse passkey values, meaning we don't need to recompute image embeddings for each follow-up message. Although the task of classification seems pretty simple, such models can be used to create really powerful applications. Take, for example, the video shown on the left, where we perform zero-shot classification to sort product reviews into classes defined at runtime. Similarly, we can use a zero-shot image classification model like Clip to do the same, but for images and videos. The video on the right shows a model running at 20 frames per second on an RTX 2080. Taking this idea further, you are even able to build games using the simple image classification models. For example, Doodle Dash is a real-time ML-powered web game that we built that can run on both desktop and mobile. The game is inspired by Google's Quick Draw, where you're given a word and and a neural network has to guess what you're drawing. In our version, you have 1 minute to draw as many items as you can, one prompt at a time. If the model predicts your label correctly, the canvas is cleared and you get a new word. Since the game runs locally, you don't have to worry about server latency at all. And the model is able to make real-time predictions to the tune of over 60 times a second.
So yeah, so if you want, so yeah, super dope. You can check that out. We spoke about Transformers.js before. The web neural network, I haven't done much with that, but that seems pretty cool too. So let's take a quick listen to that one.
Hi, I'm Rob Kochman. I'm a product manager on Google Chrome.
Hello, I'm Rafael Centron, and I'm a developer on the Microsoft Edge team.
And we're here today to talk about the Web Neural Network, or WebNN API. It is an upcoming potential web standard API that a bunch of us in the community are working on. And so I'm going to talk a little bit about why we're doing this. And I guess, we talk about a new API. In my job as a product manager on Chrome, I'm focused very much on enabling advanced web applications. And we talk to a lot of developers, and the way those conversations usually go for web app developers is, they go on and on about how awesome and great the web is. And then, when they're done with that, more often than not, we hear that it is very difficult to keep up with all the changes in the web platform, all the additions, all the new APIs. And so when we start talking about a potential new API, I've got to do the annoying product manager thing and ask, why do we need a new API? Why is this important? And so I'm going to talk a little bit about why WebNN exists, and then Raphael's going to do the interesting part and tell you how it works. WebNN, before I hand it off. So I haven't actually said what it is yet. So it's a specification for executing neural network graphs, and we'll talk a little bit more about what that actually means. But that's what it is. Fairly simple, at least conceptually. As an eventual web standard, we intend for it to be the support to be built directly into web browsers. And so we've done this in Chromium already as an experiment, we hope to see that elsewhere longer term. And then for all those browsers and the various OSs work together to handle the integrations with the hardware. And by hardware, it's NPUs are the focus, but
we're gonna go and keep going through, but you can see more of that. Again, I posted a link to the playlist. You can check it out. All right, I'm almost out of time, but real quick. So here, check this one out here. Let me I think they had some demos. I just want to show some demos of this. So this is ML5.js, and it kind of reminds me of TensorFlow a little bit, I think. So, so you can see they have this Deep Learn JS. So TensorFlow. Yep. Deep Learn JS becomes TensorFlow JS. So develop examples into a P5JS library, the ML5JS. Okay, so it's using like P5, I guess, with like TensorFlow stuff. That's pretty dope. Let's see, workshop. Let's see if I think this one had demos. Yeah, so ML5 in action. Let's check this out.
Does ML5 look like in action? So machine learning frameworks are typically geared towards people with somewhat advanced knowledge of linear algebra, statistics, data science, and years of programming experience in a language like Python or C++. Obviously, I don't need to speak to you all about how accessible the web can be. So we wanted to present a way for folks to think creatively about how to use machine learning as a creative platform. So ML5's examples are all built using P5.js and the P5 web-based editor, which means that all dependencies, all model weights are available using a single script tag. In this example, you can see face key point detection, which the model is instantiated, the webcam feed is grabbed, and the output of the model is visualized, all using about 35 lines of code. So in practice, what this allows is for students to very, very quickly get up and running in jumping to the creative use cases. And these might be in building interactive installations, in building web art projects, and they might integrate with other libraries like Three.js.
Nice. So you can check out more on that. This one, speaking of creative uses, big shouts to Charlie. I saw here. So exploring alternative interactions in JavaScript. I actually met Charlie. Oh, damn it. Oh, crap. Okay, wait a minute. Okay, now it paused. That was weird. I met Charlie at Google I/O when I went, and then we met again because we were both speaking at Render ATL. Super cool person, and they presented here as well. They do a lot of cool like demos and stuff. There you go. So let's see. So yeah, so here's Charlie playing what are those like Beat Saber games they made. Here we go.
Instead of having joysticks, I would play with my hands. So if we could just roll the video, it's about a minute, and you'll kind of see what I'm talking about.
Cool, super dope stuff. Check that video out. I've been kind of playing around with this, the overview of Chrome built-in AI. I have like a whole nother browser. So I was going to show this at some point, like AI built into Chrome. I haven't got a chance to really do anything with it, but let's take a quick look at this. All right, let me scroll along. Do they explaining it? I think they had a demo. Again, I was kind of like just watching this while I was playing in the background a little bit. Let's see. Oh yeah, so yeah, they have like the summarizer API, prompt API. Okay, here we go.
You can send your prompt, you get a response, you can experiment. This has been available since Chrome 1.27, and we are launching an origin trial in Chrome 1.31, starting with Chrome extension. So pretty soon you will be able to use this API for real with actual users in Chrome extensions. All right. Next up, the Summarizer API. So as the name implies, this is great for condensing long text into bite-sized summaries. This is perfect for TLDRs, bullet points, headlines, you name it. This has been ready for prototyping since Chrome 1.29. And here again, we want to do an origin trial in 1.31. So the team back in Tokyo is still working on it. Hopefully it's going to make it.
So that's pretty dope, summarizing a long text. They have this translator one, which is pretty dope. Here you go. I might have to go back a little bit. Let's try this one here. Come on, play. Please play. Play. All right, my internet is not liking this. Hold on.
Origin trial in 1.31. So the team back actually live right now. You can go to the origin trial dashboard, users. All right. So companion opinion to that, the translator API. So as the name implies, you can use that to translate between different languages. This is available in Chrome 131 for local prototyping. We hope that we...
That's all in the browser. So check out the video for more stuff. That's pretty dope. Let's see. TensorFlow.js one, real life case studies, web extensions. I've got to look more into that. This seems pretty cool. I'm trying to... Okay, this is the one I think I just recently saw. And I'm like, oh, this is pretty dope. I think this is the one. Yeah, it's one of the last ones. All right, check this one out. We might look at... I think I have the thing pulled up. You can check that out also. But he goes through some pretty cool examples using the media pipe. I think we spoke about this before, but it's cool to see this video. Oh, man. Yo, these... Okay. As soon as I go to hit the pause button, the back button shows up. Okay. So let's see. So he talks about media pipelines. Pretty cool. You can do a lot of cool stuff. They're using it with like in Google Meet and everything. And then they're doing this cool thing where there's a company, I forgot where, but like the presenters in the front, and then like people's comments are on the screen behind him. It's like going behind him. So it's like, it's pretty dope. They're using image segmentation, I think it is, to cut him out from the background and then have the thing go behind him. It's pretty cool. So you can kind of see it. Wait, show it? Yeah, you can kind of see it here. So that's pretty dope. Cool. I think, what's this? Let's check this one out here.
Keeping image segmentation as our example, here's what an implementation might look like today. Note that most of the code here is just for specifying configuration options and paths to the WebAssembly and model files. The overall usage pattern is much simpler. First, initialize an image segmenter, and then run segmentation whenever results are needed. We support a handful of other computer vision tasks as well, like detection and tracking for faces and objects, or posed landmarks for faces, hands, or human skeletons.
Cool. So that's a lot of dope stuff. Now, he's also talking about, so experimental LLMs. So there's some experimental stuff. So kind of like what they were saying before with like the Transformers JS and running these different things. So now they're like doing that inside of the browser. So it's pretty dope.
Primary focus so far has been on speed. We wanted to see just how fast we could run LLMs completely on device in the browser.
Yeah, that's pretty dope. All right. Let's see. There was one where he did, I think, image generation. He had like cats and dogs on it. Here.
This is a highly optimized image generation model running in Chrome via WebGPU, producing 512 by 512 images in under 2 seconds. Perhaps most impressively, though, this video was also recorded live on my 5-year-old MacBook Pro 2019 and has not been sped up at all. Thank you.
That is kind of amazing. That's in the browser, like on device. There's no sending stuff off to like other servers. It's all on the device. That's kind of amazing. So you can check out more from that. They have a lot of cool stuff here. So I just wanted to talk about that. And I was looking at, was it this one? Well, I saw some different articles and stuff. So he has links to different things that you can check out in the slides. So you can check out more of all that stuff. But yeah, that's it then. I just want to talk about that really quickly because I thought that was super cool. And so, yeah, web AI is going to be a thing at some point, which is kind of amazing. Like stuff is going to be, you'll have like I guess like slimmed down LLMs built into the browser that you can then do things locally. You know what I'm saying? So I don't know, I think that stuff is pretty cool. And so yeah, so I'm kind of slowly playing around with stuff, but I think it's still pretty cool. All right, let me know what y'all think. If you got a chance to ever play around with that stuff, what do you think? Let me know. But I'm gonna send y'all off get back to work because I want to get back to work. There's a bunch of stuff I'm trying to get done. And so I'm gonna send y'all off with some Nujabes featuring Apani B. The track's called Thank You. Thanks for hanging out. I'll see you 15 minutes after the hour. Till then, I wish you much productivity, and we'll take a look at an artist's website, listen to some music, maybe watch some videos. All right, thanks again, y'all. Y'all be easy, and peace. Thanks, y'all.
Let's start from the heart. I'm exploring state. I think you all for showing up to me. I appreciate this unique opportunity. I'm gonna rock so hard you never stop supporting me. I'm gonna show you how music is more meaning to life. I thank you all for showing up to me. I appreciate this unique opportunity. I'm gonna rock so hard you never stop supporting me. I'm gonna show you how music is more meaning to life. But let me start from the heart. I just want to stay. I thank you all for showing up to me. I appreciate this unique opportunity. I'm gonna rock so hard you never stop supporting me. I'm gonna show you how music is more meaning to life. I thank you all for showing up to me. I appreciate this unique opportunity. I'm gonna rock so hard you never stop supporting me. I'm gonna show you how music is more meaning to life. But let me start from the heart. I just want to stay. I thank you